Welcome to Inside Builder channel. Getting started with Huggingface Vision Tasks. 8 vision tasks that you can perform inside Huggingface Hub, a open source artificial intelligence model hosting website. The vision tasks that we are going to look at inside Huggingface are listed here. There are 8 different tasks that you can see here, and each of these tasks have their own assigned number of models which can do these tasks. So if you have seen my earlier video on NLP tasks, that is natural language processing tasks, there I have explained around some 10 different or 11 different tasks that you can perform. And like the same way, each of these tasks have many different models that can do the same task. So we will be seeing these tasks and the respective models in action in a couple of minutes. But before that, I want to give you a brief about, because you might have come directly to this video from the internet through search or some other means of locating this particular video. So what I would suggest is that if you are new to this entire series, then start by looking at the earlier videos that I uploaded inside the playlist, inside the playlist that I have called as the Learn About AI Language Models and Reinforcement Learning. This particular playlist contains all the necessary videos that will not only give you the details about the AI models, it will also provide the complete ecosystem surrounding the AI models. So in ecosystem using Python, so all my videos are related to Python. You will get an overall picture about the entire ecosystem. So that will give you a overall understanding. With that said, the topic that we are going to discuss today is about various vision tasks. When it comes to vision task, you will need an image, and that image needs to be fed to the model, and the model has to do the prediction, right? In order to do this model prediction, you need to have a model. That particular model can either be pulled locally to your environment. That is what the local inference means. And you can have the model hosted somewhere inside the server, and you can send the picture that you are going to work with to that hosted model, and you can get the prediction back as response. That is called as Huggingface inference route. Depending on the performance of your particular machine, so your machine might be very powerful, so 32 GB or 64 GB RAM with i7 processor, or it could be a Raspberry Pi also. So if it is going to be a very high performance machine or a server, then local inference will be a better choice. And if you have a GPU, then it's well and good. But if you are having a low performance like a Raspberry Pi or your smartphone, then Huggingface inference will be the best option. Okay, keep one thing in mind. When you are going to use Huggingface inference, you will be given the API token that is called as HF token. That is what I am telling here as Huggingface token, that you can get it from the Huggingface website. So let me go there for a moment and show you that. So this is what the Huggingface website looks like, and I am under the tasks page. You can see the various computer vision tasks. So in the earlier video, I had discussed the natural language NLP tasks also. And here, if you see under each of these tasks, we see various models, and each of these models have their own benefits and their own disadvantages, their own biases. So I have already explained this in NLP tasks, but I would see this point is very important. That's why I'm even repeating this. Each of these models, so for an example, in case of depth estimation task, we have the model Intel DPT-large. So if you click on this particular model, you will be taken to the models page. So each model has its own page, and you can take a look at their deployment methods, and also you can take a look at the inference methods like transformer pipeline methods also. So you can take a look at that. Why I actually brought you here is to take a look at the model card. So the information that is provided here, this is called as model card. They explain to you everything starting from how it is trained, on what data set, what is its benefit, what is its disadvantage, what are the results, what are the biases, and also the ethical considerations. Everything will be listed here. So ensure that you understand to read these things before you use the model in your task. This is something that I have to inform, so that it will be easier for you when you are convincing someone. That is more important, right? So for an example, you might use a model, and suddenly any of your other team members or your seniors might say, okay, you cannot use this particular model. So you might have to discuss with them ahead of time that, okay, can I use this model? The model, or what is the specifications, or what is the parameters that you need to check inside a model before you can use it. So these kinds of questions you need to ask your stakeholders and your seniors. Or if you are going to be that senior, then you should also understand that as a senior leader, you have to understand the ethical considerations as well as the applications that the models are going to be used. So this model card will guide you that how to use these models, because there are certain biases that is already inbuilt into these pictures that are taken for training. I'm not going in detail about that. The point I am trying to make here is that read through the specification and try to understand. And if you have any questions, if you need any clarification on reading the model code also, I'll be able to make a separate video about that. That will be a different exercise for me, but yeah, that will be a good thing that I can share it with you guys. If you want it, do leave a comment and I can work on that. Going back to the presentation, as I was explaining about the HF token, after you understand the task, then for understanding the tasks, you may not need the signing up. So you can directly go to the Huggingface hub and you can start looking at the tasks. But if you want to really get the token and start working with the inference API, then let us go back to the browser again, and you have to sign up, and then you have to visit your page, settings page, and from there you can get the token. Yeah, this is about the overall point I wanted to share about Huggingface hub. Clear? And yeah, let us move to the discussion in the PDF. Now that I have given an overall picture to you about the tasks that we are going to deal, the models that we are going to work with, and also how we are going to get the inference, let us go to the next step. So in order to do the inference, there is a separate API. In order to do in order to do Huggingface inference, there is a separate API. If you want to do local inference, you can use transformers, pipeline class, model class, and tokenizer class. So there is something called as auto model and auto tokenizer class that I'll be showing you in the Colab notebook in a couple of minutes. And also remember that transformer pipeline will pull the model down to your local environment. So, and also load your random access memory with the model. So ensure that your random access, you keep a eye on the random access memory. So if the models keeps on loading, then you will be out of memory very soon. And then the system will not crash, but the program will crash because the RAM is completed, right? So the program will crash. I will show you how to work with that in a couple of minutes. You have to basically restart your system. There is no other way to purge the RAM, and that is one of the points that I wanted to share. And when you are working with inference API like Huggingface inference API, if you have a lot of inferences to do, it's better to go for local inference like transformer. But if you are going to have one or two inferences, say per minute, or the inferences which is less in number, then go for Huggingface inference, because this Huggingface inference API is a free service that is provided by Huggingface hub. It's better that you use it with care. See, they have sufficient power. I'm not telling that they don't have power, but it's provided as a free resource for everybody. So keep that in mind so that others also will be able to use it. And sometimes you will also see when in my own presentation, when I'm going to show it, the inference API might return an unknown error. So sometimes it may not be able to give the reply to you because it's either the inference API is busy or the model is not loaded, or it could be various other challenges that comes with Huggingface inference API. Such challenges are rare, but once it comes, you should know how to recover from it. So we always have the local inference option, that is transformers pipeline. Knowing both of these methods will help you a lot. The code that I will be sharing will be uploaded in the GitHub repo. You can take a look at the repo. I will be sharing it in a moment, and we will move to the Colab notebook next. If you like the video, do leave a like and share it with others. Subscribe to my channel. So further updates on LangChain, large language models, vision models, various other AI models, data will be shared in this particular channel, and any update will be directly coming to your YouTube dashboard once you subscribe. Let us move to the browser right now. In the browser, we are going to go to the repo. So inside the repo, the notebook that you see here will be shared with you guys. The link will be shared with you, and you can start using this particular notebook for your purposes. So you can fork it and start using it. Next is that we have seen this. One thing I wanted to share with you guys is the COCO dataset. So most of the models that has been trained are based on the COCO, Common Objects in Context dataset. It is available for anyone to use for free on the internet. You can review this, and if you want to go in depth into vision models, this is one of the websites where you can get a lot of datasets to work with. So you can take a look at this particular link, and you can start working with it. This is something that I wanted to share, not because that I want to tell about this website, because in the Colab notebook, when you are going to work with the API, when you are going to work with the models, you will need a place where you can get the pictures, correct? So this could be a better place. So you will have lots of pictures here. So that is the reason also I am sharing you this particular website. So I hope that you guys understand the reason behind that. Now that we have introduced all this basic building blocks, in case of Colab environment, I have Colab environment is a place where you can run Jupyter notebooks. It's a virtual instance that is provided by Google, and you can see that it has almost 13 GB of RAM, and already the model is using almost 10 GB. So that is because I have loaded considerable number of models. In case if I load additional 2 or 3 more models, it will cross the limit of 13 GB and the system will crash. So what we can do, usually what is the process is that you have to just go to the runtime and say restart runtime. So it will restart the entire runtime and you will recover the RAM back. That is how you have to work. So I just want to show you guys, you don't need a GPU for most of these things except one model. This unconditional image generation model, this needs GPU, and also it takes a lot of time to download. If you are going to use it in local environment, be careful about this model. Okay, I am not also going to explore in detail about this model in this series that I am discussing right now in this video. Rest of the models I will be showing you step by step because they are small models basically. Okay, so that is the details. Let us go back to the PDF for a moment. In the PDF, I had shared the various tasks, but in the Colab notebook, along with the tasks, I also shared the various models that you can use with these tasks. The default models that comes when you pull these tasks inside the pipeline, right? I have also uploaded that. You can take a look at these models directly inside the Huggingface hub. So in this place, you go and click on the search models, and you can start searching and start working with that. I've given you the overall picture about this. This is something that you can start with. We have already downloaded the various libraries here: transformers, sentence transformers, Huggingface hub, and LangChain. LangChain we may not be using, but I am keeping it there by default. So you can download that also. It's not going to take a lot of effort. First and foremost, we are going to work with depth estimation model. Okay, so depth estimation model will see and estimate the depth of any given picture. So the picture that we will be estimating the depth is 2 cats. I mean, one of the most often the things that you find in the internet is cat's picture, and we are going to use it, and you will see the depth estimation will return a result like this. So wherever there is a higher depth, so you will see a white, and wherever the depth is low, you will see the white is little less. So that is how it looks like an X-ray graph, but yeah, that is how the model returns back the values. So we do not do a lot here. Actually, what we did, the transformers pipeline class actually abstracts a lot of complexity that goes into this. What happens when we pull in when we execute this particular command is, let me go back to the presentation. It starts by pulling the model first thing, and then it starts by pulling the tokenizer, and then it initializes the model and the tokenizer so that you can send in the data. Why you need a tokenizer? Why you need a tokenizer? That's the first question you must be thinking. When you ingest the data will be in form of certain type. It will be JPG. It will be some other format of text also. Once you push it into the model, you need to be you need to have only numbers. So tokenizer does the conversion of, it does two things. It first of all splits the picture or the data, and it converts them to numbers, and then it feeds to the model. The tokenizer knows that what is the dimension. So all the each part of the picture or the data is converted into array, the torch array, and when you are going to convert it to an array, there should be a specific shape to that array. All this concept of shape, the how the array should be formatted, all these things will be taken care by tokenizer, and it will be sent to model will process it, and it will give you the prediction. So this is the actual process that goes on, and this entire step of creating the model, creating the tokenizer, all these things gets abstracted by this particular function called as pipeline. So you have to execute this with the task, and it pulls the Intel DPT large because we did not supply the model. So if you supply the model here, so if I say a comma, and if you supply the model here, then you will get that specific model. This is about so you see the entire function that is getting shown here. So like this also you will get the data. So the task, the model, the pre-trained configuration, the tokenizer that we are going to, we can give every detail to the model. That is, it's not going to stop you. You can also tell what type of model it is, what data type the model parameters have, and all the necessary information is already available to you in the docstring. So this is called the docstring that it has been created for this pipeline. So you can take a look at that also. So it gets automatically popped whenever we hover our mouse over the the function, or if you go and hover over here on the class, then also it will get populated. So you can use this for your understanding of the each and every class inside the Python libraries. As I was telling, the Coco dataset, I have given the link here also. This particular cat images came from Coco dataset only, and I have pulled it locally by using wget, and I am using IPython library to display the images for your reference. And here in this case, I am not actually using any IPython library. I am just calling result. I am sending this d underscore model is created by using this variable. So d underscore model is the pipeline. Inside the pipeline, all I need to do is give the path of the image. So the image path is here. If you take a look at my folders, the image path is here. And by default, once I give this image image name, it automatically starts processing it. So that is how the model, that is how this particular pipeline has been designed. So you must be thinking, how do you know all these things, Kamal? It comes with practice. Let us go back to the presentation. Whenever I end my presentation, I always say this, that the reason for giving you the Colab notebook is to practice. So once you start practicing it, you will start seeing, okay, there will be certain places you will not understand what is going on. And even in my videos, I would have skipped a lot of things because I am explaining to you with the intention, with the objective of covering as much information as possible. So what will happen is sometimes I might skip, or I might even forget that, okay, I missed this particular aspect. So you can always, remind me that, okay, do explain it again so that I can explain to you over the comment or something. In case if I miss it, then when you are going to practice it, then you'll get the doubts. So that is the reason why I always say in my videos that you should start practicing. And it is one of the most important, most understated point that I've seen around recently. So the more you practice, the faster you learn the libraries, the Python ecosystem and the Python environment, especially for artificial intelligence related topics. So how much time you spend with it, the faster you will master it. Okay. With that said, let us go back to the browser. I've given you a fair understanding about the depth estimation model. The same process, we will be using it for other models also, right? I will be showing you one other way using the inference API, the inference endpoint, but at this moment, this inference endpoint is not working properly. So I use this Google model V80 based patch for working on the next topic. So the classification, I wanted to use the model. However, I am getting the unknown error when I am using the using this particular model. So you need to have the API token here. You need to place your API token. Also here also you can place the API token. So yeah, here also you can place the API token. Two places you have to use. So if you are going to use LangChain or some other library, then you should use Huggingface of API token as environmental variable inside the OS. The Colab notebook runs on Ubuntu. Okay, so you need to place this inside the environment, or if you are going to use inference API, then you have to excuse me, send it as a header inside your post request. That is how it works. And inside the post request, you can give the picture location, and it will directly start querying. So this particular function is a helper function that does the querying to the API endpoint. Anyway, here it's not working. So what I did is I went ahead and pulled the image classification model, that is Google VIT base patch, to my local environment, and then I did the classification. So this particular picture that you are seeing here, it comes from, just a minute, let me actually show it to you. So this is also coming from the Coco image. So this is the image that we are referring. So there is a car, there is a there is a parking meter, there are palm trees, there are buildings, everything, right? And I'm going to use that, and I am going to send it through a classification model, and out comes the various classifications. So I see the parking meter is given the maximum score because that is in the foreground, right? And also we see that there are trash cans, we have mailboxes, we have shopping cart, and all those things are having very less number of scores. So from this score we can say, okay, this picture is about parking meter. This is the classification model, the image classification model. Okay, so we will be using this image for a couple of things. Okay, so this is the image that I was talking about. Next is image segmentation. So this image can be segmented. So you must have heard of the segment anything model that was released by Facebook. So Facebook has a lot of other models. So you see this Facebook close. You see this Facebook DETR RESTnet 50. So before they released segment anything, they had released a lot of other models inside Huggingface itself. In order to use this image segmentation, you need to install TIMM. So install this particular library before you use this. And once you get the pipeline, it will download the model to your local environment. You see this downloading process here. And then if you send it to segment, you can actually get the segmented result. And what will happen is you will get each segment. So you will get the speedometer, you will get the parking meter, you will get the location of this car, you will get the location of the trash can. All the things will be given to you separately. So it's one of the one of the most important tasks that you need to master inside the image, inside the vision tasks. Of all the vision tasks, this is very important. What happens is, let us go back once to the Huggingface hub. You will see there are various use cases. Okay, so one good thing about Huggingface hub is that they don't just give you the models, they also give you the various use cases where you can use it. And say for an example, you want to understand what is the use case I can use for image segmentation. So click on the task, go into the task, and you can see the use cases right there. So it is used by autonomous driving. It is used by it's used for background removal. I told you right in the beginning of this presentation, I informed you that this particular image has the background removed. So there is a white background in this image. I have removed it completely. And how did I do that? There are other ways. We can use OpenCV and we can remove it. But instead of using any of the traditional methods, we can use let us go back to the browser. We can use the model. We can use the model, and also we can remove the background because we have segmented it. So we have segmented the background and we want only the parking meter. Then we can actually get that parking meter alone. And you know what is the benefit? You can do it programmatically. So this is the benefit of working with even the other version is programmatic, but this is more important as you might want to take the segmented image, then you want to send it to the next step, like object detection, or you want to use it in case of autonomous driving. You want to check whether a pedestrian is crossing or someone is crossing, something is there in the middle. So like that you can use this. So this is something that also I wanted to share with you guys. And so I have initiated the image segmentation, and I'm going to send the image into the seg underscore image variable, and once I send it, what will happen is it will take a little time, because I am running on a 12 GB RAM virtual machine. It will take a little bit of a time, and it will give the output. So let it give. In the meantime, I will also start explaining the other things. Next, what I will be discussing. Yeah, we see the output here. So we see that there is a car. We see there is where it is. There is road. There is parking meter, and inside the parking meter, we can actually get the mask also. So each of these masks you can get it. So for an example, if you want to, okay, here it's not assigned to a variable. So let us assign it. Segment underscore variable. You see this data structure, keep this in memory, because we need the mask. Basically we need to look at this image, how the mask is, right? So that is the intention of this particular exercise. That's why I'm assigning it to the variable right now, so that you guys can look at the mask. Or else what will happen is I have to do a very cumbersome activity here. That's why I'm assigning it to the variable, so it will be easier for you guys to understand. Okay, in the meantime, the next will be image to text. So where I will be giving the same image, and you see that I am getting the output 2 parking meters on the street with palm trees. I mean, it is one of the best outputs that I have got from the models, and that too it is available for free. You are not paying anything for this, right? The model is getting downloaded to your local environment, and then you are getting this kinds of inference. And think about it, if you are going to create if you want to check the various things that is happening in your product or in your service that you are offering, then you can think about the use cases for image to text, correct? So let us this particular activity has been completed. So what we will do is we will take the segment variable, and let us take segment underscore variable 0, and we are going to look at the mask, right? This is the first mask that we are going to look at, and the moment I call the first mask, it's an image that we are going to get, and you see we are getting a part of the mask. So what we will do is we will try to change, say for an example, let us go to the 5th one. We can actually take, so you see the 5th one, it's more of the background that we are taking a look at, and let us see about 6th one. Like this you can actually explore. So you see this is the parking meter, right? You remember that? So this is the parking meter, and this is what I was trying to tell you guys, that you can actually play with the mask also. So that is what I was talking about. On the same image, we sent it through the image to text, and next we are going to work on object detection. Object detection, again we are going to send the object detection through the pipeline, and then we are going to, so object detection again uses Facebook model, and we are going to send it through the object detection, send the image through the model, and you see that we get the output as okay, I think I have to initialize this. Just a minute, guys. So sometimes when I am restarting the runtime, I don't load all the models. So what will happen is if I load all the models, this model, as I was explaining, the RAM will cross the limit. The memory will cross the limit, and my notebook will crash. So that's why I'm not loading all the models. And now the model has been loaded, and I can detect the objects inside that. So you see, this reply is little different. When you did the segmentation, you got the masks. But when you are doing object detection, what is happening is you are getting the actual classification of each of these objects. So we see the parking meter here with score of 0.99. It's so confident, and it also can confidently classify the car that is available. So this is one of the benefits. Also think about it. You can actually take the data, and you can find out how many parking meters are there and how many cars are there, right? This is you can start counting, and once you start counting, you can also use it for other purposes also. That is the main intention of understanding these models in your day-to-day activity. And this here it comes to the discussion about the video classification. This video I had taken it from Pixabay. So let me show you the video. It's a very small Christmas. Just a minute. Let me show you the video. So this is the video that I was talking about. It's a simple Christmas present ball that you see inside the Christmas tree. That is what I have tried to work with in this model. Let me close this also. And okay, this vision video model has its own challenges. So the way to work with the video model is that you have to import these feature extractors and video classifier, and it doesn't stop there. You have to encode the video. So what will happen is the video itself, when you look at the data, it becomes numbers. So it is encoded into arrays of numbers. You see there are lots of arrays in this. It's not a simple image, right? It's a video. So video will have both X, Y axis, and also will have time axis. And each of this picture will have lots of information. So that is what you see here. It has been extracted into tensor numbers. And then we send it through certain processes. I'm not going to explain you each and everything about this because it's not going to be helpful in this introduction video. I would like you guys to take a look at the picture, take a look at the explanation inside the Huggingface hub. So that will be much more beneficial for you also. And the model that we are going to use is MCG NJU. So this is the model that you are going to use, and we are going to pull it down. And I'm going to just send the model, send the inputs that I got, and I actually get an output that it's picking fruit. So yeah, the model is not perfect. It takes a lot of time to retrain it. But once you get a good model, then yeah, we can actually classify the video also. So this is one of the process that you can use. Next is when it comes to the just a minute, let us go back to the presentation. The point where I told that unconditional image generation, this particular point I'm not going to create. I'm not going to experiment in the Google Colab notebook. So I will show you why. Let us go back. Because what happens is, you have to first of all install diffusers, and this is going to work on stable diffusion, and it is going to use DDPM model from Google. It will start pulling the model. So if you start pulling the model, right, it is actually a huge model, and this particular RAM will not be sufficient, and it will immediately crash this particular notebook. So that's why I did not pull this image. You can try it out if you have a higher RAM machine, or else don't try this out locally. You can do a inference, Huggingface inference, but even that might be a little bit difficult. Okay, so just know that it is possible. If you guys have a better machine, then you can try this. Okay, and finally we have the transformer pipeline where we do the image classification. So we can classify the image zero-shot classification. This is called as zero-shot classification because what you are going to do is, we just now saw that this is a parking meter image, right? There is parking meters, cars, etc. So what I'm doing is, I am creating this pipeline, zero-shot image classification, and it gets a model, and I'm initiating this model. After that, I tell to that model that, okay, see, I think that this particular image might contain cats and dogs, lions and cheetahs, rabbits and lions, and I ask it to classify. Okay, and out comes the score. So you see, it is still telling that rabbit and lions are still there, almost 50%. Cats and dogs could be there, 31%, and lion and cheetah 17%. So it's actually wrong. But when I tried to actually change the classification label, so I told meter and car, palm tree and car, and rabbit and lion, then when you see that for meter and car, I get the score of 0.999. So it is classifying perfectly. And rabbit and lion, it is minus, you see the difference, right? It is in minus e to the power of -8. So you understand the power of these models, correct? The point I am trying to make in this particular video is that to give a test drive of all these models when you are experimenting is more important, and when you are going to use it in a project, you will know what exactly the model is doing. But suddenly, if you are going to use it in a project without any kind of research, that will become a challenge for you. And also, if you are a leader and if you want someone to use this models and make a product, you should also know the what is it called, the pros and cons, the capabilities of these models also. You may not, see, there are lots of high performance, highly cost sensitive language models and vision models are getting released. And also at the same time, there are open source models which you can use it reliably, and you can also tweak it if you want to your own application, as well as your own budget. So all these things are possible. So depending on the type of product, depending on the type of application that you're using, you can decide whether to go for a very costly model or a mediocre model, which is cost effective, at the same time does what you want. At the end of the day, all these models are there for a purpose, and that purpose is to solve a problem. It's not going to be a solve all model. It cannot do that. So every task has different models. And yes, there are videos, there are language models and artificial intelligence models that has been proliferating, which can connect various models. Like all these tasks that you see here, you can actually connect it using language models like ChatGPT and GPT-4All. You can do that also. And you can use libraries like LangChain to bring these things together and stitch it together. All these things I have explained in the earlier videos. You can take a look at that. I hope that this video gives you an overview of the various tasks that we spoke about and how to use it in with transformers. And I hope that you like this video. Do leave a like and share it with others. Subscribe to my channel so further updates on the large language models, artificial intelligence and vision models, and also various Python libraries, because libraries are the bread and butter of this AI ecosystem. So I'll be sharing most of the things that I research myself, and also provide you some of the ideas on how you can use these models for your regular products also. So with this, guys, I would like to end this video with 4 words as usual. Most important thing is practice. So practice. See you guys. Have a great time.